Hey everyone, how are we doing? It is about time to do some data analytics, getting things off the screen right here. Was doing some work. All the work. Oh, we don't even have Mubot awake. Are there people here yet? I don't even have the stuff on the screen. I don't even have. I'll go over here to this. Mubot's not even awake. There's so much going on. I feel like I have the chair lower too. Hair's getting long. Mubot's awake, waking up. It's one of those days. It's a Wednesday. Oh man, I just had my first statistics test. I think I did well. I hope I did well. I teach statistics. I should do well, right? Let's hope I did. Hey, Ty, good to see you there. See Ty in the chat. Getting everything going. Briley, good to see you there. Did you guys, gals, pals, want to? Will, good to see you there. You want to do some data analytics? Is that what we should do? What's the vote right now? Data analytics, chapter 5. I sent out data analytics, so chapter 5 or data analytics. Delaney, good to see you there. What should we do? Chapter 5 or data analytics. Anu, good to see you there. What should we do? Get some work done is what we should do. Data analytics is winning. Data analytics. I wants to do data analytics. We've done a lot of them so far. Man, we only have, after this one, we only have 3 more left. And we get a break? Look at that. We're going to get a break between doing these. It's going to be amazing. Okay. With that, let's take some notes right here and get started. I want to ask, so let me do this on the getting started. I want to put this in the video because people are going to skip to this part. Here we go. Data analytics, full pivot charting. Oh, wait, getting started. Oh. You good, Puppet Shark? You good? Thank you, Puppet Shark. With that in mind, you can say it in the chat, I just want to hear, has anyone been getting 10 out of 10s on all their data analytics? I hope people have been getting that. That's kind of the goal. Has anyone in the chat been getting 10 out of 10s? And offer some advice. Like, if you've been getting 10 out of 10s, offer some advice for people. Be like, hey, here's how I've been doing it. Yes. Riley says yes right there. And it's your grades, you can talk about it. Any advice? Here's my advice. Lauren says yes. Anu says yes. My advice is always look at the rubric, because the graders are going to be clicking these things right here. Like, did you put that information at the top? Did you upload all the files? Did you take an appropriate screenshot? So make sure to include the correct things in your screenshot. PivotChart has the right information. Great job, Karwan, right there, and everyone. Descriptive chart title, descriptive vertical axis titles, data table elements. Significant digits should be 2 or should be logical. I think we say 2 through it. And then a write-up. So you got to do those write-ups and the AI reflection. So, I mean, all in all, and look, here's the thing people often lose points on. Don't worry if you lose points on it. A lot of people forget to put numeric backing. Numeric backing is when you actually give the numbers. When you say something like, the mean for Group A was found to be 12.5, while Group B was found to be 13.5, which was 1 point higher. These differences were not that large and found to not be statistically significant with a p-value of 0.94, whatever. You know, I'm just making that up. So you want to give the numeric backing when doing it. Well, you know what? Let's just jump right into it. So we are going to start this up right here. Now, if I miss something in this, please let me know. I will let's throw 1,000 points with some Mubucks right here. But if I miss something, if I make a mistake, I'll be like, Brian, you made a mistake. You made a mistake. Now, there is a bit of a problem. I can't really use this file lest I'll be doing the assignment and someone could do exactly what I'm doing. So I'm going to go back. I'm going to go to Data Analytics 3 and steal that file for the moment. So which file are you using? It's like I got to put that warning up again. Which file are you using? Which file are you using? Which file are you using? I'm going to put my block up on the screen real quick. Make sure I'm opening files. Okay. Yes, great job right there at 30,000 points. Yes. So as Karwan says right there, if I mispronounce anyone's names, please let me know. Please, please, please. You are not using this file right here. Do I need this? Should I have this warning up? Yes or no on the bottom of the screen? Like when I'm doing these, should I have this warning up at all times to warn people? Like, I just really think sometimes people click every button I click because I've had people be like, I did what you did. And I'm like, but I was telling you I'm doing something different, because they might just like skim through the videos. So I'm like, do you think I need this warning up? What's up? Good to see you, Tyron. All right there. Do you think I should have this warning up? What do people think? Or does this get in the way? This is the last little bit of housekeeping we're doing right here. Keep the warning up or don't keep. Once 2 people say it one way, we're going to do it. Keep it up. Veronica says yes. One more yes, and it's locked. One more yes, and the warning stays. Well, it might be 1 vote. Keep it. All right, let's do this. Once again, let's put a note. We are starting the assignment here. So getting started, make sure, thank you everyone for saying that. Let's show you some more points. Make sure to look over the rubric, and let's do data analytics 4. And let's say making the pivot table. So you are, of course, going to have your Word document. You got your Word document over here with your Tizble in it. Open up your Word document on your other screen and then bring it down to this screen. And put your information. The easiest way to get the information is to simply go here, copy the information here, and then enter it in so that it has the same format, but make sure to change it. I think everyone knows what to enter in. If you've been getting these points, you'll continue to get these points. Just make sure it's there. With that, that is 1 point out of the way. We're going to learn how to make some pivot tables. We're going to filter some data and generate clear professional statements. And let's go down here to the scenario. You're using this data. I am not. You're going to select 2 categorical variables. I will too, and 1 quantitative variable. So let's show how to make the pivot table. I'm going to timestamp this right here on how to make a pivot table. To make a pivot table, simply click inside of your data. With your data clicked inside of it, hit Control A. That selects all the data. Now go to Insert and then Pivot Table. Both a Mac and PC will have in this area. Don't click the drop-down menu, just click Insert Pivot Table. We're going to go ahead and click OK to put in a new worksheet to give some more area to work in, more room for activities. Now, we have the start of a pivot table right here. With this being the start of a pivot table, I need to select 2 categorical variables. You can tell, and I'm going to go back and view the data, if something is categorical, if it has usually names in it. There are other things like ID is an identifier, a special case categorical variable. I wouldn't use it though. Don't use that. It's kind of a weird one. You're using different data also. I'm going to pick for my 2 categorical variables, the day of the week, and also I'm going to look at high walk-up demand. So now we go back here and we put day of the week, which I think was this, into rows or columns. And you can also search, so you can type walk-up here and get high walk-up demand. There's my 2 categorical variables, as the assignment says, inside of the rows and columns. So we've completed this task. What kind of variable do I need to pick next for the one we're going to look at the values of and look at the average? So someone for 1,000 points in the chat, what kind of variable, what type of variable? Because we have 3 types of variables, it's kind of 2. It's kind of a special one of categorical called identifier. But I need to pick another type of variable for 1,000 points. What is it? And it's going to go in the values, and we're going to look at the average of it. What kind of variable are we going to pick? What kind of variable? Quantitative for 1,000 points right there. Also means you're in the chat and you get the points. Mubot beeping away at the bottom of the screen right there. Boop bop beeping away. Well, let's think about this. Probably the most important thing to look at would be demand. Whoa! Well, these demands are all the sums of demands. With these being the sums of demand right here, we don't want the sum of it. We want to go right here and click this. Now on a Mac, this will look like a little eye. You're just going to click right there on a Mac or PC, and you'll see value field setting. This is the setting for this field that controls how it calculates. Right now it's calculating the sum. We're going to click value field setting, and then we are going to click on average and click OK. So now we're saying instead of doing the sum of all these observations, like how much demand there was on a certain day plus how much demand there was on a certain day plus how much demand there was on a certain day for not high walk-up demand on Sundays, we're going to average together the observations and get averages. Now this looks a little bit crazy. Any suggestions to me on what I should do? Maybe I should what the decimals in this. Once again, just kind of following through, and I know what the assignment says. We'll make sure we don't miss anything, and if I do, you tell me. What do you think I should do to those craziness of this? What should I do? What should I do? Any suggestions on how to make this look more pretty? Any suggestions? Looks kind of crazy right now. Round to 2 decimals. I think it says to do that, or a logical amount. The key says a logical amount. The assignment says to 2. What you're going to do is you're going to click the topmost cell with a number in it. Then you're going to click the bottommost cell in a number, but hold shift. Everyone hear what I said? Hold shift while doing this click. When you hold shift, it'll select through everything. So you click the top and then you hold shift and select through everything. Then make sure you're on the home screen right here and go to the delete decimal button. There you go. Now we're doing this before making the pivot chart. We're making it in our pivot table so it'll be organized. Good to see you there, Pate. I'm going to zoom out a bit. You can scrunch in on your computer like this. It's usually on the Mac or PC, like on the mouse pad like that. Or if you have a mouse, you can hold the control button and pull back on the scroll wheel. So we're zoomed out a little bit because now we're going to click inside the table and go to Pivot Table Analyze and click Pivot Chart. Clustered column. Well, there we go. Let's go ahead and click OK. So with this, we're going to try to get it nice and perfect. Now, there's a lot of ways to improve this graphic, but there's some quick ways. If you click on the Design button, you can go to Quick Layout, and usually this one right here in the center has a lot of what we need. Notice everything's already rounded because we rounded it in the previous step. So now with this right here, we only need one more axis title down here on the bottom. To get that, I go over here because the Mac usually doesn't have that button. It's over here for both a Mac and PC. You have to be clicked on the chart itself, though. Some people wonder I can't find it. Make sure you're clicked on the chart itself, and then you should see under Design, Add Chart Element, Axis Title. Make sure it's not Axis. I've done that before. And add a primary horizontal axis, and you can see the name of it now. So now our chart basically has everything we need. We'll double check things here in a moment, but you want to give descriptive titles. Like this would be the average demand. This would be day of the week. We can't really label that, but it's high walk-up demand, yes, no. So maybe what we could do is we could add a legend, and we'll add it to the right. Wow, look at that. If you click some of the text, you can make it bigger or smaller by increasing or decreasing font size. And I wish it would just do all the text. Maybe we click here. Yeah, it did. I was like, what if you just click the chart itself? I think it's looking pretty good. You can change your colors if you want. You could fill in a different color. It's all your choices. There's so many things about how you should make graphics and how they should look. Got like a nice Easter graphic here, maybe. It's a little too light. I don't know. It's what you want. As long as it looks nice, you could probably argue for your grade. So make sure it looks nice. Just have some fun with it. That looks crazy. Sure. Perfect. And yeah, now fill in your graphic. So with this right here, I think we've done everything. You need to fill it in. I could fill it in too. You know, think about what this axis should be on the bottom. Think about what this axis should be on the side. Remember, it's an average. And think about we've got a legend over here on the side. What do you people think? Is this amazing? Is this a really good chart? I think it's actually got some bit of information in it. If you look at it, it's actually got interesting stuff. Because you can see demand is highest when. Demand is highest when. And we actually got it in order. I don't know how I lucked out. Maybe it knew to put it in order. But if it's not in order, you have to click and go to this little thing right there and drag and move, and it'll reorder. What's up, Manoa? You're talking to me about, not me, though. You have to go to right there. It's so hard to see, but it's right at the edge. And you have to drag if it's not in order. I don't need to reorder mine, but I'm just showing you. You can reorder if you go right to the edge of the box and move it. But mine does not need to be reordered. So let me ask you this. What screenshot, and once again, fill it out. You got to listen to what I'm saying. Fill it out. Not cut it out this time, but fill it out. Well, now we're going to cut it out. What is wrong with this screenshot right here? I want you to think if someone presents to you this information, just logically speaking, why is this screenshot? I mean, other than me not filling in the titles, which you need to do, logically speaking, what's wrong with this screenshot? Logically speaking, like you go to a meeting and they're like, here's our information. Logically speaking, what is wrong? For 1,000 points, logically speaking, what is wrong? And then we'll start the write-up portion. Then we'll do some chapter 5. Anyone have any thoughts on what's logically wrong with this? What is logically wrong with it? Well, the numbers under the bar are good, but you're on the right track. So, and we're gonna double check everything, make sure I have everything right. Well, think about this. The information here and the information here is what? Oh, Delaney, that's actually, I was thinking about that. Hey, you got two eyes, and you're like, what's going on? What was going, like, what are you supposed to look at? Delaney, really? Yeah, it's like, where am I supposed to focus on this? Does that make sense? Like, why we got two things here? Because this is redundant information. So if all this information is contained over here, you click on the image and you go to picture format, and you crop your image, because we don't need that extra stuff. Now make sure once again to fill in everything, but you don't need the extra stuff. It's redundant information. So now we've cropped this in, and then we expand it. Does this look pretty? Actually, I think I'm more partial to this nowadays. Does that look like a pretty, I mean, I didn't fill it out completely yet, but does that look like a pretty good image? Like you would put in a presentation, like here's our information. I mean, I'd say yes. You can see what the groups are. You can see what's going on. This is a presentation you can throw on a report. Like, here's the data on what's going on. It doesn't even look like a screenshot anymore. It looks like an actual graphic that you want to display, not like I screenshotted a screen. So this is what we're going for in your screenshots. They should be clear and easy to see. They should be well composed. So you want to go towards this idea of like, I can just crop it. To crop the image, you go in and you click it and go to picture format and click the crop button right there. Let's talk about the write-up though. Okay. The number one thing you have to know about doing your write-up is to mention what's. The number one thing you have to know about doing your write-ups is to mention what's. You have to mention what's. Let's go look at the key again, the rubric. You have to mention these. You're going to lose points if you don't mention them. You're going to be like, oh no. The numeric values, nice job right there. The numeric values. You have to be mentioning the numeric values. Mention them in your write-up. There's the visualization format right here. Descriptive chart title. Add that in. Descriptive vertical and horizontal titles. Data table, elements below the chart. We added that. Significant digits. So it looks like we'd get full marks on this. Appropriate screenshot taken. Good. Make sure you put in the right files. Can you confirm your bar chart? Nice. Colin, I'm so excited to see you. 5,000 for Colin from Disney right here. And professional write-up with clear insights, all this stuff right here. And so we're really just on to the last part of interpreting this. Getting all those MeWe today. Okay. So ask ChatGPT, we did that. Well, we did ourselves. Write a brief, clear summary, 4 through 6 sentences, a high-level takeaway. What story does this tell about UT students? Well, we're doing bikes right here. Any interesting relationships or patterns? Okay, so let's do this. If you filtered the data, removed any blanks or outliers, explain your rationale. So I didn't filter or remove anything. So let's go drop this in and talk about it. So here we are. What story does this tell about UT students or the bikes? Oh, thank you so much. I'm excited to see that. Please, yeah, share with me or share what you can. I'm excited to see that. So if anyone doesn't know, Colin works at Disney and does really awesome things. And I'm just really proud. Like, we have students at Disney, we have students at the Lakers, students who work for the Rangers. I mean, like sports and entertainment, and it's really cool. That's the greatest thing about being a teacher is when you get a little bit older, not that I'm older, you get to be like, I taught that person. I think I'm gonna have a student who's gonna be like a novelist and a politician. That's my next things. And we got Veronica giving some great insight here. The insight is the middle of the week is the highest, and we're gonna quote that number. Great job, Veronica, right there with some more points. We're gonna say Wednesday on high walk-up demands had the highest demand with 7,330.75. We typically see, whether high walk-up demand or not, the middle of the week is where we see the highest walk-up demand around Tuesday, Wednesday, and Thursday, where it hovers around or a little bit above 7,000 when there's a high walk-up demand week. During the non-high walk-up demand week, it actually peaks on Tuesday with 4,305.98. The lowest demand was seen to be on Saturdays on not high walk-up demand with 2,421.34, and also Sundays. The high walk-up demand also follows this trend with 5,780.89 on Sunday and 5,504.01 on Saturdays. It's clear to see that when it's a high walk-up demand, oh, you missed the it's clear to see when it's high walk-up demand that demand is almost twice as much in some cases. It's also clear to see that the middle of the week is where we have the most demand, whether it's high walk-up demand or not. I probably have like 5 sentences right there, right? And notice how I'm mentioning the values, I'm talking about the relationship. I'm just saying what I see. So did I give did I tell what's going on with the data? Yeah. Did I mention anything interesting about like the middle of the week is the highest thing? You can see it right here. The middle of the week is the highest. Also, there's a difference between the high and the low walk-up demand. Did I give numeric support? And then I'd say like no outliers were removed in analyzing this data. No blanks or outliers removed. So, I mean, you think about it, we're done. That's it. We spent like not even 20 minutes. I think we're good. Now we just have to write a reflection. Make sure to do the last little parts right here. There's our write-up. We wrote that. And then AI reflection. So just do this right here. Are people finding these? What are your thoughts about the data analytics? Are you each week you're like easy 100? I hope. I know not everyone might be getting hundreds, but I really want people to be like, I got this, and they're all right. And please give us, you can give critical feedback on them too, because these are new this semester or a new format. I had a student being like, I had a student in this class, and they told me they didn't use ChatGPT. I'm like, well, we changed things up. We want your thoughts on it. We want your guidance on it. Education is for you. We even had a student saying, I wish I did this in Stat 201. And we're like, well, we're sorry. Be overthinking it sometimes. Me too. I'm always overthinking it. I can't show my test online, but because like it's a test. But I told my wife, she's like, you teach stats, you'll be fine. I'm sorry. I gotta stop. I got a problem. It's been a crazy week. It's been a crazy week. Anyways, should we do some chapter 5? Chapter 5. Gives you Excel tips. Nice. Chapter 5 part 2 homework. Yeah, let's do chapter 5 part 2 homework. Let's do the full homework. Who wants to decimate that homework? We don't complete homework here. We decimate them. So let's cut. I just scraped my chin when I was shaving. I didn't shave for like 5 days, and then see, like that is. Why can't you just pick if you want to ever grow? Like, I wish there was a way that you could be like, I never want to grow a beard or a mustache, and then you would just be like, no facial hair. Why? And then I don't even have like, I have little patches right here. Like when I grow, like I've tried. Well, there's the opening where the shattered opening where it shows me with like a beard for a moment, and my wife saw it and she was like, no beard. I showed her like she was doing her internship at that time. Brian, that was data analytics 3 and not 4. Am I wrong? That was 4, right? That's 4. Mm-hmm. That was 4. That was it. Wasn't that bad? I mean, like, it was like, wait, was it another one? Yeah, that should be data analytics 4. And Pate, you might be wondering on the data set we were using. The data set was from Data Analytics 3. Does that make sense? That was Data Analytics 3 data set. Veronica said right there. We're gonna get started here on a moment. Sorry, I need my energy. Okay, let me get the applet. Oh my God, applet. Okay, let's get started right here on the Chapter 5 homework. Okay, Stat 201, Chapter 5 homework. Yeah, you'll use the data set on there. That's 100% use the data set on there. Good questions, Pay right there. Use the data set it tells you to use. Remember sometimes, and I might show it again, I might use a different data set. That's key to what I do. Let's go to the main screen. Really good question, Pate, because I have this warning down here, like Brian's doing something similar to you, because I want students to like not be able to copy what I do, because if I use certain data sets, one could just copy every step I do. So you have to think what variables are categorical. Javante, good to see you. You have to think what variables are quantitative. You have to think what variables are categorical and all that stuff. Unrelated, but for studying for the upcoming exam, what videos should we watch? Let's actually do that really briefly right here. So we'll put preparing for the upcoming exam, then we'll jump right into this homework. I'll give that advice because that's a really good kind of quick segue. Exam 1 or Stat 201. Exam 1 preparation. So here's what I would do. If I was preparing for the exam, I would go and I would forcible morb. I would start watching the speedrun videos. So you can find this with review 1. Mubot's about to post it here in the chat. I would go through and start watching. For those who haven't seen, I gotta play it.
Epic Stat 201 speedruns of statistics. Brian Stevens versus Chapter 1. Stats start here. Begin.
It took me like a whole day to make that intro. It took a whole day to make that intro. There's so much to it, and there's just like this was the coolest. I'm just having fun for a moment. This explosion of this right here, I had to do the overlay on this text. So that's just a bunch of random different text to look like epic rap battles. But the coolest thing, and it actually dims and comes back. It starts at a level, dims, and goes out and explodes across the screen.
Epic Stat 201 speedruns of statistics.
Explosion.
Brian
And then I had to overlay myself with this. So you notice my head is in front of the Brian, and then I'm behind the Steve. That's not that hard. It's layers.
Versus.
And then, yeah. And that's a green.
Chapter 1. Stats start here. Begin.
And I used the same screen, but then I dimmed the background, and yeah. It's fun. You see it has the speed run behind it. So I cheated a little bit. Once I made that first screen is what took like 2 or 3 hours to make, because you're just like, you got to make it look good. Nice. But yeah, so I'm glad people like these. A little bit of fun, a little bit serious. What I would do, so my advice for this, and then we might do some chapter 6 and stuff. So we'll probably hop back to chapter 6. What I would do if I was you is find what videos work best for you and focus in. The Morbin. Forcible morb right there. I have other ones down here going through the material. Chapter 6 correlation. You can go through here. You can see what I talk about, everything. So then we even show that graphic to this day right here. I showed that in class. But you can go through. It's just a different way of reviewing. Javante, no, get some sleep. Relax, Javante. Relax, man. Get some sleep. And don't. Morbin, exactly. And it's just what works for you. So my best advice is this. You want to study in 20 to 30 minute segments and then take a break. It's the Podomoro method. And just put your phone up. You take your phone. Where's your phone? Take your phone, throw it. And with your phone thrown to the side or up in the air, you relax and you just focus for about 20, 30 minutes. You go over a topic, you write notes down, you write down questions, and then you take a break. Don't be scrolling on TikTok. Don't be looking at Instagram. Don't be on Reddit. I know they're all fun and interesting, but you got to put it aside. Maybe print out some notes. Have a notebook, a physical notebook. Try writing things down to help yourself remember. Try saying them out loud. The more you can focus in, the better you'll do, I think. And you can see the topics and everything here on the exam 1 page. So that's got it. Well, that's my advice. Find a schedule that works for you. Start going through the videos and reviewing. Okay. You ready for who's ready for some chapter 5 homework? Chapter 5. Pearson has review questions, but Canvas content is the #1 way to know what the exam looks like. And the Kahoot also this Friday at 3 p.m. So come to the ready for the homework. I like it. So come to the Kahoot Friday, and you will see a good kind of example. Step 201, chapter 5, part 2. Homework. Okay. So for this question right here, we need to use the applet. Now, on the exam, you'll probably get pictures of the applet. And with the pictures of the applet, you have to know how to look at them. So I might trick you with 1 or 2 of these questions. So This one, the first thing you do when you get to the applet, if you're using it, is enter in your what or what. What do you enter in on the applet first when using it? What should you enter in first on the applet when using it? The first things to enter in will be the what and the what on the applet. The mean and the standard deviation, which are found right here. So the mean weight is 1152, and then the standard deviation is 84. And now it asks what percent of steers are over 1300. Well, right now we're finding X using the p-value, so we're going to switch it up. And great job right there, everyone answering. We're going to find the percent using X. So we're going to type in here 1300, and then we're going to go above. So let's go above. And we might need to do to 1 decimal if we're doing like 3.9, so that'll be the answer right there. And you know what I'm going to do? I'm going to put this side by side on the screen. It's a very good way to view it. 2 seconds, you'll be able to see it. And there we go. So now you can see the applet on the side, and you can see the answer. So it's going to be 3.9% rounded to 1 decimal. You can change the rounding over here, really nice and neat, makes it very easy to use. This one, I'm going to show you the answer, but not really, like it's a test question. So imagine the test question gives you this. What percent of steers are below 1225? Now, this is what the test question shows you as a graphic to use. So what's going to be the answer over here? What percent of steers are below 1225? Does anyone know? What percent of steers are below 1225? See if you can figure it out, and then we'll talk about how it's found. What would be the answer? I have it. Do you? So this is what the test shows you, but it's not the answer. Because it says 19.2% is above 1225 on a curve with a mean of this and standard deviation of this. So as long as we answer this right. So what is the right answer for the amount below 1225? Any guesses? What do you think? It's a good thing to know how to solve. Be like, wait a minute. 19.2 is above here. What is the area below here? Yeah, Veronica, that's it. That's all it is. Yeah, great, Veronica. You saw that's the math. Yeah, it's going to be 80.8, right? And you can just click the below button to confirm the answer. So yeah, so you just, and once again, just seeing how to solve it. This one right here, we'll just solve it. We can just go to between. I'll do a few more where we have to see how it would be on the test. We can just go to between 1025 and between 1125, and there's the answer of 30.9, and it looks graphically accurate. Once again, a pro tip on the test is to immediately draw the normal curve. Immediately draw it and use it. Maybe I'll do the next question that way as though we're taking it on a test. So sure. We're going to pretend right now that this is the test. So let me mark this as question 2. Because a very common question I get, which is a great question, is how are you going to test this on this if we don't have the applet? Does that make sense? Like how, if we can't use the applet on the test, how are we going to get tested on it? Well, let's examine that. So here's how we could test you on this question. So this question, we're going to grab it. Our beautiful graphic. And let's see. Okay, if you got this information, and let's just say this is all you have. What are you going to do right here with this information right here? What are you going to start doing? What are you going to start doing with this information? What did Joey used to say on Full House? You know what he said. What do we do with this information? Which you should also do at the start of the test. You can't bring it to the test, but you're going to draw it out. What do we mean when we say draw it out? Draw it out. Aiden knows for 1,000 points in the chat. Draw it out. Ask your parents. They'll know. I gave you in right there. And so here we go. You go up 3 standard deviations and down 3 standard deviations, which is not the full, the curve is infinite, but it only goes, like,
It doesn't matter.
the rest of it doesn't really matter outside of 3 standard deviations because that's 99.7% of the data. So we're going to put right here, and I usually like doing this. What am I writing first? Who knows for more points? I'm drawing the what curve, or these are what below it. What is this curve called? And what are those below it? This is the what curve. Anyone know? This is called the standard, kind of, well, you can do a 68, 95, 99.7 on this. This is called the standard normal curve, and those are z-scores. So z-scores are in terms of a curve with a 0 mean and a standard deviation of 1. And so these are z-scores, and if you draw the curve with z-scores, it's called the standard normal curve because everything's been standardized to z-scores, so we call it the standard normal curve. I should get some hair gel. Okay, here we go. Also on the curve, we put what I call the context of the problem. And we go right here, and we're going to go up 5.3, because that's the units of standard deviation. We go up and down each time. So now we go to 26.2, and then we go to 31.5, and then we go to 36.8. Now we go down standard deviation units to 15.6, and 10.3 and 5. Woo! Purdy. Now here's the thing. If we're using the applet, can we just enter into the applet these numbers of 20.9 and 5.3? And then the applet will draw it out for us? Will the applet just do all the work for us and do a little weird rounding down here? Does everyone see that? Yeah. So the applet's going to do the same number line we just did and draw the curve out. I don't know what's going on there. We'll just ignore that for the time being. So you want to just be able to replicate what the applet's doing. I want people to take a guesstimate of the area above here. So the first question is 32. The area above 32. Just a guesstimate. It should be a little bit less than what? What is a guesstimate? So here's a hint. If you do this, it's less than this because it'd be from here over is this, but it's not totally that. 1.3 is a good guess. That is a good guess. 1,000 points right there. I don't think it's quite 1.3. Well, not 1.5. 2.5. 2.5 is from here over, and you might be right. You could be right on your answer. It might. It's probably like 2.2. Because it's a little bit less. It's a little bit less. It's probably like 2.2 or so. Does that make sense? It's got to be less than 2.5. And so that's the orange answer right there. It has to be less than 2.5 because 2.5 is above 31.5. How about under 19? Under 19. Oof. Oof. Of course it's going to be in the middle of the curve. 19 is going to be about here-ish. What is a guesstimate for under 19? What is the guesstimate? Just guesstimate it. This one's really tough, though. What is the guesstimate? Yeah. What is the guesstimate for under 19? Just guesstimate it. Well, 68 is between here and here. Yeah, it's probably about 36%. It has to be more than 16 because 16 would be below that point. So it has to be more than... Does it make sense? Who follows me that it has to be more than 16? It has to be more than 16 because 16 is below this point. Because that's outside of the middle 68%. So it has to be more than 16%. So it's more than 16. 36 is probably a decent guess. So we'll take our guesses right here of 2.2 and 36. 2.2. Oh, we get one more guess on this. Let's go 2. No. Okay, let's use the applet. So on the applet, you have to enter in the mean and standard deviation and then go above and 32. It's 1.88, and you were closer than I was. My answer of 2 is very close. It's 1.8. So that first drawing we did is not 2%, it's 1.8. Did you get it right with 36? You might have. Let's find out. Dude, Aiden, did you go 5,000? Did you guess that or solve that? Aiden, did you guess that or solve that? How did you do that? Did you guess that or solve that? Either which way, congrats. You saw. Oh. You still got the right answer. You still got the right answer. Give me a second. Give me a second. My brain is blinking away. Blink, 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 blink. above, below. Oh, no. There we go. So how did I do that one? How in the world did I get that question? Wait, yes or no? Did Brian use the applet to solve that last question? You got to rewind the tape for it. Did Brian use the applet to solve that last question? Did you see me use the applet to solve that last question? Yes or no? Where'd my graphic go? Oh, it's on the thing here. Did you see me use the applet to solve that last question? No. I'll show you why. Because of what we knew. So we found out, and we can use, oh, really? So because of what we knew, you might have seen the math, right? Yeah, and I did the math wrong first. First time I did it wrong. Okay, so here's what we found out. We found out that this is 36, and we found out that this over here is 1.8. Now the answer for the last one is this area. So how in the world are we going to get this area right here? How would we get the blue area? Which the blue area turns out to be 62.2. So how did we get it? Aiden has it. Aiden, shout outs Aiden on fire right here. So you can also use the applets, but it adds up to 100%, as Aiden's saying, 100 minus. You've shaded the full curve right here, so you can just use the applet to get the answers of going between, and then you just enter in the values. I think the top value was 32, and then the bottom value was like 19, and there it is right there. So subtract from 100. So great work, Aiden. If you look at our drawing and this drawing, you should have something kind of similar. And there's our drawing and this drawing right there. So it does look kind of like it, where there's that remaining 1.8. And then there's the bottom side on the curve with the, 36%. Does that make sense? What I've done right here is I've shown how we can kind of solve some of these and take good guesses. And applet pictures could be used. But that's a really good question to see like how to draw it out and how to solve it. And try doing this right here as much as you can. So really good stuff. Cool deal. Let's solve the rest of these. It's going to show I didn't do that one now. Well, this is an easy one. Man, why has it got to be easy? We should have the most difficult questions ever. Chapter 5, Part 2, Homework, Question 3. This is all about a normal probability plot. A normal probability plot. A normal probability plot. So what in the world is a normal probability plot? Well, here's data. So what is this graphic called right here? What is this graphic called on the screen? Oh, yeah. I can fix it, Veronica. I fixed someone's last night. If it's a rounding issue, let me know. Yeah. Message me. I fixed someone else's. Close, Aiden. A bar chart has separation between, let me see, bar chart versus histogram. A bar chart has separation between it where a histogram does not. And they're showing a really good thing over here. I'll take a screenshot and bring it to this side. And you can see the small difference between a bar chart and a histogram. Is a very good way to describe it. Not as stacked, though. A histogram has a numeric number line. So the histogram is for quantitative data. So whenever we see a histogram, we'll see numeric data on the bottom. Also, no gaps, as they point out. A bar chart is for categorical data. Remember, you can make a bar chart of your favorite pies and a pie chart of your favorite bars up here in the top corner. They're interchangeable. So you can make a bar chart of your favorite pies and a pie chart of your favorite bars. So it's categorical data, and we see the counts in each group. And then here we see how many are in each bin. So this graphic right here is called just a histogram. That's a histogram right there. It's just memorization stuff. It gets tricky. And here is, here is the same data in a normal probability plot. Doing it weird ways. How does a normal probability plot assess if the data is normal? How does a normal probability plot figure out if the data is normal? So a normal probability plot is a plot that shows us the probability it's normal. If the histogram is mostly normal, the normal probability plot will look what? Who can finish that sentence, which is a good sentence to write down? If the histogram is mostly normal, unimodal symmetric, then the normal probability plot will look mostly what or follow a what? The normal probability plot will look mostly what? Who knows for 1,000 points? Anyone? Good note to have. Good guess. We'll throw you 1,000 for the guess. Not really uniform. It'll follow the line. So this red line down the center of it is a perfect relationship between the normal and what we see in our data. I'm talking about this red line down the center right here. So what you're looking at is these dots are your data. Your data. This line is the normal. Well, what is expected given a normal? Like, if it matches the normal. That's impossible to read. We'll make the pen smaller. The normal. It's as small as it can go. The normal. The normal. So you're asking, does your data follow the normal? These extra lines are kind of the meh lines. Like, if they're kind of like, okay, it's kind of within the bounds. It's like a little bit the guardrails on what is normal. We don't exactly call it a trend line. It is a matching what is expected line. It's not kind of like regression. We're not doing regression here. That's where there might be some confusion, especially when we get to chapter 7. It's saying, I expect my students to follow this path, and then here's what my students did. Did my students follow the path, yes or no? Yes, just type yes or no in the chat. Did my students follow the path? Yes or no? Yes or no? Did my students follow the path? So this is the path I expect them to follow. So if you were to plot this, you'd start with the red line first, and then you'd say, did my students follow the path? Yes. So the normal probability plot lets us see something is normal the more the points are along the line. The line is always where it's at. The line will always be, and if you're wondering how it works, it matches up the following way. It matches a 1-to-1 where you see 3 and 3 would be at. That's where the line is best I can draw. I should just hit the line and go to the left and go down. If you hit over here at 2 and go down, you'll get there. If I could draw, that'd be good. And if you notice, like if we go to 0 and 0 and I hit where the line's at and I go down, that's where 0 is at. So it's matching where 0 and 0 and 1 and 1 are at. It's my favorite way to make a normal probability plot. So when you think about this right here, how does this histogram look? What kind of monster man are we dealing with right here?
What kind of monster man is this?
Who knows what kind of monster man we got going on? Right to the high, left to the low, whatever way the monster man's tail goes. What kind of monster man are we dealing with? What kind of monster man? Right skew, high skew, positive skew. No one gets those wrong in my class. We don't get monster man stuff wrong here. So tell me, does that look normal? Remember how a normal probability plot works? The line is what we expect to see if it's normal. So you're saying, I expect my data to be along this line. Is your data along that line, yes or no? So this is the same data we just saw, but plotted to check if it's normal. Is your data along that line? Got handsome Squidward over here. He's going, it's right skew. It's right skew, right to the high, left to the low. You don't really have to know skewness with the normal probability plot. The number one thing to know is if it follows the line, it follows the normal. This is different from a goodness of fit test. I won't review that right now, but a goodness of fit test is a different way. So, yes or no one more time. Is this data normal? That's a perfect Squidward. Is this normal, yes or no? Is that normal, yes or no? No, not at all. Doesn't match up. The line is what is normal. Data doesn't follow the line. No, because it doesn't follow the line. If it isn't normal, well, they want us to know right skew. Squidward answers that. It's whatever way Squidward is like going like. I could do left skew data here if I multiply these by -1, so I can replicate some left skew data. If I go times -1, yeah, there we go, and then we'll times it by -1, and you can see that that's left skew. You'd be over here and going. Does that make sense? Which way I think of it, like it's like pushed out in that direction towards the left. That's not on the test. It's on this one thing. But I guess I mentioned, like, you know, it's easier to see in a histogram what way it's skewed. You can also tell there's too many high values. They're higher than expected because the line is what you expect, and the observed values are higher than the line. The line is what you expect. So there's too many high values, especially this crazy high value up here. And this one, there's too many low values. They're lower than what you expect. You're below the curve. So low values is left skew. So, like, if there's, yeah. It's tricky, or that last one, but I mean, there's the answer. Okay, just a few more. What should we do after this? What do people want to do after? Because we're kind of doing a mini lecture in this too, which I like. That way, if people watch this, they can hopefully understand the topics better. I don't know why I just copy paste this full everything I just wrote. We got a histogram and a normal probability plot. Let's look at the histogram. This one will be quick. What is not so normal here? What is not so normal here? Don't even read their question. Just listen to me. What is not so normal here? Remember, normal is woo. What's not so normal? What's not so normal? Any ideas on what's not so normal? Woo. It's kind of rigid. Well, what else? Well, I mean, think if you draw a perfect normal on this, where does it have there? Do you see it now? Take a good look. And what is deviating from normal? I'll draw more hints. I mean, if you were to imagine you want to make this a perfect normal, you'd go in here and you'd be like, does that make sense? A little bit bimodality on the low side, right? So that means we're going to see weirdness down here at the bottom. Does that make sense? This is going to be the weirdness. The crazy biggest pen we've ever seen. So we're going to have some weird bump at the bottom. Is there a weird bump at the bottom here before we remove the outliers? This is with the outliers. There's this weird bump. And that's how it shows up in this data. It shows up with a weird bump down there. And then if you remove them, it looks more... I mean... Remember how a normal probability plot should look if it's normal? It should follow a straight line. This is with outliers removed. I mean, that looks about as straight as it can get. So with the outliers, it's got some weirdness that deviates from normality due to probably the bimodality of it, and which is seen down here in the second smaller modal area. And so the data are bimodal with a high and low mode. If it was normal, it would have 68 between 1 and 2, and 95 between positive 2 and negative 2. I think that's right. I don't think it's right skewed. Really? It's not right skewed, is it? Are they mad about that? No way. What am I doing? Nah. Please tell me which button to uncheck. Not that one. A, B, C, or D? I'm going to need to move my head. I misread something. I know the answer. And I can point to it. If you listen to what I said, that's the issue. It is D. And what should this read? I said it. I didn't read it. Because I know the answer. 68, 95, 99.7. What should that read? I said it as I was like clicking on it, and I just didn't read it. I've done this question like 50 times. 68. It should say 2. Mm-hmm. So that's... Oh, Dubai! I didn't uncheck it. Oh my gosh. It should... Yeah, I didn't uncheck it. Why did I recheck it? I don't know. Okay. The normal probability plot has problems because of it. What do these plots tell you about the shape of the distribution? The shape of the distribution with it removed is more approximately normal. Yeah, we saw that. So once again, it's within one standard deviation of 68% of the data. There's a low and high mode. And if you remove the modal area, you get a more normal. Without it, it's less normal because the more it follows a straight line, the more the normal probability plot follows the normal. So with it removed is more approximately normal. There we go. What kind of graphical display helps us determine if something is approximately normal? What kind of graphical display? Who knows? What kind of graphical display helps us determine if something's approximately normal? What kind of graphical display helps us determine what is approximately normal? It's almost like if you read it backwards, it says what? A bar chart is for categorical data. A box plot shows the 5-number summary. A frequency chart is for categorical data. And histogram, I'll show you. Histogram's kind of jaunty. Let me throw you some points for that. Kind of. The answer is D. And histograms are for quantitative data, but here's a problem. Let me ask you, is this data, let's go. What is the shape? What is the shape? Oh. Is this skewed data? Let me redo it. Yes. What's the shape of this data? What's the shape of this data? Remember, uniform is flat, but I'm tricking you because how you do the bins, like the number line at the bottom, determines how it looks. So I can increase the amount of bins and it starts to look a little different, but this is the same data. Notice this count of how many are in each bin is getting lower till I get to like individual observation or each one of the observations. We can probably go even bigger here. Yeah, there you go. So now it's just 2 observations at max in that area. But you could go where they're basically all in the same bin, all 40 observations. So it's actually right skewed data, and you can see it when you properly do the number line. But a normal probability plot, known as a quantile plot, that's why it's QQ, lets us see, and there is some right skew to it. Squidward is pushing to the right there on the data. So the normal probability plot, also known as a quantile plot in some disciplines. But remember when we read it backwards, it's a plot that shows us the probability it's normal. So read it backwards, remember what it is. It's a plot, that's what this is, it's a plot right there, that lets us assess the probability, like how likely it is that it's normal. Here's one last review thing I want to do right now, though. What about a goodness of fit test? A goodness of fit test does the following. A goodness of fit test asks, how good does the normal what our distribution? A goodness of fit test asks, how good does a normal what? Think it's called goodness of fit. Your parents buy you these jeans. These are the jeans they bought you. They bought you some red jeans. And this is you. This is you right here. You're the histogram. How good do these jeans fit you? What do you think? How good do those jeans fit you? You're asking, is it a good fit? Is the histogram, the normal curve, excuse me, is the normal curve a good fit? Is that a good fit? Fashion Society, so positive, we're a little more mean than Fashion Society because they're some of the nicest people ever. But is that a good fit? Yes or no in the chat? Is this a good fit? Yes or no? Does this red curve, I agree, Javante, no. Sorry, we're mean here. It is not a good fit. And let's look at one where it is a good fit. So here is one where it is a good fit. It might not look like it's a good fit, so I'll make it look better. There we go. Here's where it's a good fit. Deal with more observations, more likely to get a better looking normal. So now we're going to fit the normal on top of this. And it might not be a perfect fit. But is the normal a better fit on this data? You might say, it's not perfect right there, or right there, right there. But you see how this is a better fit than the previous one? Trying to fit the normal on the previous data doesn't really work when you draw the normal on it. So you're asking, is fitting the normal here a good fit? The answer is no. And then the answer for fitting the normal here is yes. I mean, you're like, wow, that's perfect to fit the normal on top of this. So how do we do a goodness of fit test? Shapiro-Wilk created one version of it. So that's the Shapiro-Wilk test for normality. And what we can do is we can run it. We'll make sure we run it on this skewed data. And we get a very, very low p-value. This p-value, if you can't tell what it is 0 point, a bunch of zeros, and then 2, 2. That should be 16 or 15 zeros after the leading zero. It's about that. And so here's the notes to have. Very important note. When we do a goodness of fit test, a low p-value indicates the data is likely not normal. Is most probably. Did everyone see this? A goodness of fit test uses a p-value, and a low p-value indicates we have evidence of non-normality. How about if our data looks like this? Now do you think the p-value here will be high or low? Now do you think the p-value here, if I run this test for this data to see if the normal is a good fit, that the p-value will be high or low? Just think theoretically. So we're asking, is it a good fit? Will the p-value be high or low? What do you think? Well, if low indicates a bad fit and not normal, then if it looks normal, we get high p-value. There's the p-value right there. So a high p, great job, Javante. A high p-value indicates the data is probably normal. So I'm going to do one quick thing right here. I'm going to put it in this video because probably a bunch of people are asking. I might even refer people to this. And we'll finish off the homework right after this one thing. Because I think, I think Charlie was asking about this. I can tell him we covered this during office hours. Stat 201, p-values on test 1. Okay. I'm going to go a little more in depth than we usually do and kind of hit upon things for late in the semester. A p-value. The p of p-value is probability value. So what is this probability value? It assesses the probability of our results or results more extreme by random chance given the null is true. So Javante, if I tell you that I can run a 5-minute mile, what would you expect me to do? So null, hypothesis, and we use its proper notation, H sub O, really? There we go. Brian can run a 5-minute mile. What would you expect me to do if you saw me run a mile? If I say, Javante, I'm about to go run a mile like I normally do, or anybody in the chat, what would you expect me to do if I say I can run a 5-minute mile? I mean, if it's true, like we're going to say, if it's true Brian can run a 5-minute mile, like if it's true that Brian runs a 5-minute mile, you expect me to finish in 5 minutes. That's exactly it. Well, the alternative can simply be Brian can't run a 5-minute mile. So it's either the case that Brian can run a 5-minute mile or he can't run a 5-minute mile. So now you think about this. Question 1. What would be likely? Is 5:02 a likely time for someone who says they can run a 5-minute mile? Is 5:02 a likely time? Let's say I'm a 5-minute mile runner. Would 5:02 be a likely time for me to run? Like something you would expect me to do? Or would you be like, 5:02? No way would a 5-minute mile runner run a 5:02. Notice it's not even 5 minutes on the dot, because you're not always going to run 5 minutes on the dot. Do you think that that's likely? Like someone who runs a 5-minute mile, do you think they would probably run in 5:02 every once in a while? Like that's something that would occur? Or do you think, no way, they're not going to be running 5:02? That's way out of line. I'd say 5:02 is likely. So 5:02 is the observation. It's our result. The probability of our results. So our observation, let's say that. Observation. Or observation is more extreme. What we see. An observation is what we see. Like I saw Brian run a 5:02. So, or something more extreme. Like Brian 5:02 is not that crazy off from his 5-minute claim. I think random variation in Brian, like maybe he's a little tired today. Maybe didn't eat his protein bar. Got a protein bar. Maybe, this is something likely. So it gets a probability, if we were to run a test, which we're not going to do right here, of something like, let's say, 70.76. Does that make sense? This would be assigned a probability by a statistician of This would occur about 76% of the time, or something outside of this to the extremes. Two-sided test. Statisticians are screaming at me. This would occur about 76% of the time. This is a likely result. And what about, Javante, if I told you I ran my hardest and I ran 10:02. So once again, this is the observation. Do you think a 5-minute mile runner, yes or no, would run it? We'll put it here, question 2. What is unlikely? Well, I've answered the question. A 5-minute mile runner shouldn't be running like when they're normally doing it in a 10-minute mile. Like if you're like, I'm a 5-minute mile runner, and then you run a 10:02 and you're like, oh, that was good. You're like, I mean, good warm up maybe, because you're a 5-minute mile runner, right? That's what you claim. So the probability of this would be something like this. This is saying what we saw was very unlikely. Does that make sense? So if you saw me run a 10-minute mile and I say I'm a 5-minute mile runner and I was tired after the 10-minute mile and you're like, Brian, are you sick? And I'm like, no, that was a 5-minute mile, right? That's how fast I usually run. What would you do to the claim of me being a 5-minute mile runner, Javante? If you saw me run a 10-minute mile and I was booking it for me, like nothing wrong for running a 10-minute mile, but I say I'm a 5-minute mile runner. Javante might know some of the words here. You would reject the claim. You'd say, Brian, I reject that you're a 5-minute mile runner. I have evidence you cannot run a mile in 5 minutes because what I saw was unlikely. So when what we see is unlikely, we reject the null. Let's put this right here. When we see unlikely results, when we see unlikely results, reject the null, evidence for alternative. When you see something likely given the null is true, when you see likely results, high p-value. Let me disappear. This is a good note sheet. Good review note sheet. So unlikely results, low p-value, lower than 0.05. Lower than 0.05. When you see likely results, you do not reject the null. People say fail to reject. I hate that wording. Just say I don't reject, because it's the same thing. And then do not have sufficient evidence for alternative. Really? Got so close to making this the way I wanted to look. There we go. So this is a very good note sheet. Now we're going to use this to talk about our terms. Does this make sense here, Javante? So if you saw me do something in line with what you expected, it had a high probability, you'd still believe I'm a 5-minute mile runner. You would not reject that claim. You'd say, well, I believe he's a 5-minute mile runner. It is lower than 0.05 if it's 0.05 or higher. Higher, 0.05, let me write it right here, 0.05 or higher. So 0.05 or higher. It has to be lower than 0.05 if it's 0.05 or higher. And there are articles on this that say the 0.05 standard is a bit ridiculous. But high p-values means something is likely. Low p-values means something is unlikely. Even Ronald Fisher himself, I've been reading a lot, had qualms about how we do some of these tests and using a 0.05 standard. It's kind of interesting learning about the history of stats as I do a PhD. Fun times. And so now let's bring it to our ideas. So let's do this. What is a p-value? So how does this relate to test 1? So when we're doing these tests right here, we are actually using a null hypothesis. For chapter 5, the null hypothesis is data is normal. What would be the alternative if the null, like your starting belief, that's what a null is. It's just a claim or a starting belief that we're going to assume is true and then see if the evidence is in line with what we assume is true. So what would be the alternative? Another belief someone might have that would differ from this than the data being normal. So the null is just a claim or belief someone has that will be tested via the data to see if we can still believe it. The alternative is going to be data is not normal. Chapter 6 is going to have the null hypothesis, no correlation, that the correlation is equal to 0. So what would be the alternative for chapter 6 if the null is no correlation? If the starting hypothesis for chapter 6 is no correlation, then what is going to be the alternative hypothesis? What is going to be the alternative hypothesis? If the null is no correlation, then the alternative hypothesis should be what? If the null is, there is correlation. Yeah, some correlation, some non-zero correlation. There is correlation. So now we have to think with what we see, what we might see. So if you have the following, here's two extreme examples. So a chapter 5 and chapter 6 example. You could see the following for your data. Or you could see the following. Which graphic is in line with the null, A or B? Which graphic is in line with the null? Which graphic for chapter 5 ideas is in line with the null hypothesis, A or B? Just the test will be done for you. You will obtain a p-value when the test is done for you. Which of these seems more in line with the null, like more likely to see if the null is true? Which of these seems like a more likely graphic to see, A or B, if the null is true? It'll actually be graphic A. Because remember, the null is that the data is normal. So if the data is normal, the data should look normal. Does that make sense? Does that make sense? Let me know if that makes sense, Javante. Like, if the data is normal, then the data should look normal. So here, we would have something with a high probability. Because if the data is normal, the data should look normal. And over here on the right, this would be a low probability, because if the data is normal, it shouldn't look normal. Yeah. This one right here, we're just looking at only the histograms. I should have done this where it's not on the screen. And then if we go down to the correlation, which of these looks more likely to see if there's no correlation? The first graphic or the second graphic? Which of these looks more likely to see if there's no correlation? If there's no correlation, let's say this has, well, I'll give it away if I do that. Which of these looks more likely to see if there's no correlation? If there's no correlation, which of these looks more likely to see? Would it be the graphic A or the graphic B? Which of these would be more likely to see if there's no correlation? So let's pretend there's no correlation. Like, if it's true that there's no correlation, which of these is a likely result? It's graphic A. And if I wrote the correlation on here, because if I say this has a correlation not perfectly zero, but like 0.01, well, that's going to have a high probability of occurring given there's no correlation. And I'm just making up these p-values to say this is a high likely thing to see. This right here might have a correlation close to 0.99, near perfect. And because of that, its p-value is going to be extremely tiny, and we have evidence that there is correlation. So I'd say I reject the null that there's no correlation. I have evidence of a very strong correlation. Up here at the top, for the first graphic, graphic A, I would say what we saw was likely given the data is normal. I do not have evidence of the data not being normal due to the high p-value, telling us a likely thing occurred, that the data, it's likely that the data is normal given what we saw. Over here, I would say on graphic B, what I observed was very unlikely given that the data is normal. I reject that the data is normal, and I have evidence it's not normal. Down here on the bottom for these, for graphic A, I would say what I observed was very likely given there's no correlation. And also, I see that the correlation is super close to zero, which is what is expected given there's no correlation, a correlation value close to zero. On graphic B, I would say what I observe is very unlikely given there's no correlation. Thus, I reject that there is no correlation, and I have evidence of there being correlation, and this is even evident with the very high correlation value of 0.99, which indicates a near perfect positive correlation. How does that, Javante, does this make much more sense? This was kind of a mini lecture over, like, I'll send it to everybody, like Charlie and everyone, but I hope this helps a lot, because a lot of people are like, wait, what's going on with these p-values? This is like, we just did a whole mini lecture. But that's chapter 5 and 6 on p-values, very much in depth, on a deeper level than just memorize below 0.05, above 0.05. It's like, what does it mean when you say something's likely? Well, you're saying the p-value is high, higher than 0.05 by the 0.05 standard, which that gets into a concept of alpha, which we could talk about that another time. But let's finish the homework. Homework. It's like one more question, right? That was normal pub. Right. Oh. Oh no, and it is recorded. Ooh. Last one here. Question 6. Okay. So this one again, we're using the applets. Using the applet. I'm really excited today for honors class. We're doing games. It literally pops up in that moment. I do teach BS 320. I'm teaching 327 right after this, and it's the honors class. We do a lot of fun stuff. So shout outs to all my students. I love teaching. I was even mentioning it earlier, like just getting to meet students and hearing about their careers and stuff is awesome. We're going to go to the applet and enter in the numbers of the mean and the standard deviation, 89930, 89930 and 85. 89930 and 85. 89930 and 85. 89930 and 85. Okay. Now, what do you notice about this curve? These are salaries. Would you want one of these salaries down here? That would technically mean you're paying the company to work for them. I don't like that. It seems that this data is probably right skewed because the distribution centered at a mean of 89,930 goes negative very quickly when you go out 1, 2, 3 standard deviations. It goes negative after the first standard deviation. So you can see that very quickly the distribution becomes negative. So I don't think this is well modeled by the normal, which is where the question is going. So let's look at their questions. I'm going to put them both on the screen at the same time right here. Yeah. Oh, cool. I think you can't go wrong either way. Am I teaching 320 next semester, Javante? I think I'm teaching 2 seconds of 320, right? I don't even know. Okay. Oops, I just disappeared. So the top 7%, well, we just go to the curve and we find out where the top 7% should be, and it's going to be right here. That's where it should be if it is normal. If it is normal, it should be there, round to the nearest dollar. Yay, Javante, that'd be awesome. There we go. Well, so now we get into, is it really normal? I don't think so. How confident are you that the answer to part A is correct? It would have to be normal. Like, this is all under the assumption the data is normal, which not all data is normal. Very little data that is singular observations would be normal. It would have to be unimodal, symmetric, without obvious outliers for it to work. Literally, this is the idea of normality. Unimodal, symmetric, without extreme outliers, because there's the one mode, there's the symmetry if you cut it in half, and you can't have extreme outliers. Choose the correct, since now it tells us about remember, the mean follows the skew. This is a classic thing we say. So you see the median is right here. So the mean is higher than the median because the mean is up here. Since the median is much less than the mean, okay, well, they all say that. It's likely right skewed. And also, the standard deviation and the mean are very close. Yeah, we mentioned that, how they're very close. It's outcompassed. So we know it's right skew, probably because of salary data too, because you're more likely to have extremely high values. Also, the mean follows the skew because if you have the median here and the mean is to the right of it, the mean's going to go in the direction of the outliers or the tail of the distribution. Yeah. Well, I think we've done a lot today. What do you think, Javante? We did the full data analytics. We did chapter 2 homework, or chapter 5, part 2 homework. I fell asleep. With that, I might take a quick break here and just do a quick walk. But I really appreciate everybody. It's been a good day. Chilling out. Maxing all cool. Shooting some b-ball outside of school. It was a great stream. Awesome. I'm like, Cullen, see, and I'll see you Friday. Yes. I'll be running around. Let me see. Tell me what time's good for you. Let me go look at my schedule real quick. Friday's a crazy day for me. I usually try Fridays off. I'm not meeting with my... Yes. Around noonish should be good. Around noon should be good. Doing a faculty... Wait. Yes. Going to a faculty meeting at 10. Going to my meeting at 11. I'm free around noon. Or unless you want to meet before that. So, and then noon, text, yeah, Colin, 5,000 points. And I love this. I saw a student last week right before the game. And he was like, Brian? I was like, hey. And he's like, I haven't seen you in 7 years. And I was like, yeah. I like that. I like it when I get to see a student who I haven't seen in forever and he's doing well. I think he has a fiance. He's a girlfriend. No, it was a wife, I think it was. Maybe. I don't know. It all happened so quick. They grow up so fast. Oh, yeah. That's, you know what I told him? I told him this. I said, every time I see you, I want to see a better version of you. That's my hope for him. My hope for him is every time I see him, I want to see him being better than he was the day before. I think that's something we can all strive for. That's something you can say to anybody. Your parents can say that to you. You can say that to your parents. They might say, what? They say, oh, my little baby's getting so old, they're giving me advice now. I really want the best for everybody. Thank you, Colin. I really want the best for everybody. I think we should, you know, it's tough. There's a lot of tough things in this world, but sometimes it's hard. Love thy enemies. It's really tough to, like, when somebody's angry at you and they're saying mean things to you, just take it in and say, I want, you know, I don't know. It's tough. And I think as you get, I'll say this psychologically, one of the last things to fully form is actually impulse control in your brain. So especially when you're younger, I kind of miss the impulsivity. I'm not very impulsive now, I guess. I'm more like logical and methodical. And I think the best thing we can do is just take a moment to pause and think a lot of times and just walk through it and think, am I going to regret this? And just to slow down for a moment, especially in business. We're going to do this back to business now. You take a moment in business, you say, let me look over this email again. Let me look over this email. Let me think about it. Let me walk through this. So it's a life lesson, but it's also a business lesson. Because I tell you this, if you're doing good business and you bring those habits to your life, like it's the same habits that make you successful in usually one sphere of life can usually, not always, usually help in others. So that's my advice to people is try to, you know, I guess lead honorably, work with others, and have a positive attitude. With that, we'll end off right here. Till next time, bye from everyone. Bye, Colin. I'll see you soon. Bye, Javante. Bye.